All right, 3-5, determining the number of solutions. So up to this point in Unit 3, we have dealt with one solution equations, all right? You've solved, you've had a variable and it equals a number. That's one solution. All right, but there are two other things that you will see that the state loves to ask you about if you read any of the math tests that you took back in August. You would have noticed that the state liked to ask you if the equation had one solution, no solution, or infinite many solutions. And if you didn't read it, okay, cool. You'll get another chance in January, and I encourage you to read that math test that you'll be taking. And, just read a few more of the questions or read some of the questions at all, and you'll see that the state really does love these. So, your actual answers for this assignment are one solution, no solution, or infinitely many solutions. Now I'm going to let you know that we have practiced one solution so much, one solution is not going to be an answer to today's assignments. You are going to have no solution and infinitely many solutions. All right, let's see what that looks like. First, we're going to look to see what infinitely many solutions looks like with the math, okay? So we attack these like all of our other equation problems. We draw our line. Now I'm going to do the right side first because there's not as much going on over here, and so it's a little less daunting. So we have parentheses, which means we're going to distribute, so we're going to multiply 2 times 3x and 2 times a minus 4. So 2 times 3x is 6x. 2 times negative 4 is negative 8. Okay. Now on my other side, we are going to distribute the 6 to the x and the minus 3. But first I want to talk about this plus 10. That is outside of my distribution zone. It's behind it. It has no job this time around, so we're just going to bring it down, plus 10. So I'm going to distribute 6 times x and 6 times a minus 3. Well, 6 times x, you squish those together, it's 6x. 6 times a minus 3, well, that's minus 18. All right, once you are done distributing, you see if you have any like terms on the same side. On my blue side, I have a term with an x and term without an x. These are not alike. They cannot be combined. But on my other side, well, I have 3 different terms. 2 of these terms don't have an x, and I can combine them. So we're going to do that. So minus 18 plus 10. If you have 18 negatives and 10 positives, well, we're going to have 18s left over. Negatives left over, sorry. And that's going to be 8, minus 8. So in this step, all we did was combine our like terms. And we bring down everything else. We brought down the 6x minus 8 on our blue side. And we brought down that 6x on our red side. Okay. No more terms to combine. No more terms to combine at this stage. We circle our term with our variable to see if we have one that's lower. Both ones we just circled are 6x. We got a red 6x and we got a blue 6x. So here's what we're about to do. We are about to math out our variable. This is a new thing. We've never done this before. Okay? So we're about to math out our variable. We're going to subtract 6x from both sides, and we're going to line it up under the term that has the variable. So they cancel each other out. On this side, we'll bring down our minus 8. And our other side, we're going to bring down this minus 8. And you're going to ask yourself the following question. Are these equal? So, are these equal? Does negative 8 equal negative 8? Are they the same? And if you can answer yes, they are the same, then what your actual answer is infinite. Infinite. There are infinite many solutions. So when you have infinite many solutions, you can pick any number on Earth to substitute in for your x's, and it would make this equation true. Doesn't matter if you use 2 or negative 438. Every number on Earth that you can think of, all of them, yes, that one too. If you substitute in for x, it would make this equation true. So that's why there's infinite number of solutions. If you math out your variable and what you have left on each side of the equal sign equals each other, then it's infinite number of solutions. That's what this looks like. Now, let's see what it looks like when we have no solution. Okay? No solution. So we draw our line straight down. Now I'm going to do the left side first because there's the least amount of stuff over there. All right, so we're going to distribute 8 times 4, and then 8 times minus 2x. All right, some of you, as I've been working with you, are like, what are those dots? Those dots is the same thing as the multiplication sign. Okay, I use dots. You can use x's. I don't care. They mean the same thing. Okay, so it just means multiplication. So 8 times 4. 8 times 4 is 32. Okay. 8 times minus 2x is minus 16x. Bring down our equal sign. All right, so I am going to multiply that 3 and 4 together, and the 4 times the minus 5x, but I want to look at what is behind the distribution zone. Plus 4x. Let's bring that down. Plus 4x. It has no job right now, so we're just going to bring it down. So 4 times 3 is 12. 4 times minus 5x is minus 20x. All right. Now at this stage, now that we've distributed, we're going to see if we have any like terms. All right. On my red side, I have no like terms. I have a term with an x and a term without an x. These are not alike. They cannot be combined. But on my other side, I have minus 20x plus 4x. Remember, the sign in front of the number always goes with the number that's behind it. Okay, so minus 20x plus 4x. Well, I have 20 negatives. I have 4 positives. My negatives are going to win because I have more of them. And there's going to be 16 negatives left. And we can't lose our variable. All right, now we're going to bring down everything else. All we did was combine our like terms in this stage. So we're going to bring down our 12. Okay. I'm going to bring down my entire red side. All right. No more like terms to combine. No like terms to combine. Next up, let's circle our terms with our variable. Okay, don't forget the sign. And we are about to math out our variable. Again, this is a little weird. That's not something we normally do. All right, so we are going to add 16x, and I'm adding it right under my term that has the variable on both sides. Cancels, cancels, and what we have left on my blue side is 12, comes down, and what we have left on my red side is 32. All right, and you ask yourself, are these equal? Okay, does 32 equal 12? Are they the same? And the answer is no. No, they are not the same. When you answer no to the are these equal, what you have is no solution. No number On Earth, doesn't matter which one you pick, whether it's 5 or negative 368, no number on Earth replacing these x's would make this equation true. So it's no solution. All right, so this is something we don't normally do. It's a new concept for us, mathing out our variable. So down here where our summary normally is, when we have one, I have a little table for you, okay, to help you remember. No solution. No solutions, you math out your variable, and the number you have on the left does not equal the number you have on the right. One solution, we have been dealing with this all along. You math and isolate your variable, and it equals a number, any number, okay? So that's one solution. Then it's the infinite many solutions. You math out that variable, and the number you have on the left most definitely equals that number you have on the right, so infinite number of solutions. Now your assignment for this has 4 problems. 2 of the problems are going to be infinite many solutions. 2 of the problems is going to be no solutions. 4 problems. If you don't have 2 infinites and 2 no solutions, something went wrong. All right, come ask. Help you find it, because you have to have 2 and 2. All right.